Lesson 5.2, Proving Trig Identities. So in this lesson, we're going to start with an identity and prove that it's true for all values within the domain. So the general process, we're going to start with the more complicated side of the equation, use our identities to rewrite that portion, that expression, to get it to equal the other side of the equation. In example 1, we're going to start with an algebraic proof to go through the general process, and then we'll start going through trig identities. So we want to prove that x squared minus 1 over x minus 1 minus x squared minus 1 over x plus 1 is equal to 2. So the general process, we're going to start with the more complicated side, which in this case is the left side of the equation. We're going to simplify and rewrite this to show that it is equal to 2. Okay, since this is a proof, you have to show all the steps. So looking at the numerator of both these fractions, I recognize that each of these is a difference of 2 squares, so I can factor this out. The difference of 2 squares, x squared minus 1, factors into x plus 1 times x minus 1. Looking at each of these fractions, I can see they have a common factor. In the first fraction, x minus 1 and x minus 1 will simplify. In the second fraction, x plus 1 and x plus 1 will simplify. Now we're just left with x plus 1 minus the quantity of x minus 1. And then if you distribute that negative through, you will have x minus x, which cancels out. 1 minus a negative 1 is the same as 1 plus 1, which is equal to 2. So we started with the more complicated side, rewrote and simplified to get it to equal the other side of our equation. So now we have proved this algebraic identity. Example 2, now we want to prove this trig identity. Tangent of x plus cotangent of x is equal to secant x times cosecant x. When trying to determine which side is more complicated, looking on the left side, we have 2 terms. On the right side, this is 1 term. So if we have more terms on one side of the equation, that's generally more difficult. So we're going to start with the left side of this equation, tangent x plus cotangent x. First thing I'm going to do is rewrite each of these in terms of sine and cosine. Using the quotient identity, tangent of x is equal to sine x over cosine x, and cotangent x is equal to cosine x over sine x. Now if I want to rewrite these as one fraction, I have to get a common denominator. So I need to multiply by sine x over sine x, and multiply the second part by cosine x over cosine x. So when I multiply, I get sine x times sine x, which is sine squared x, cosine x times cosine x, which is cosine squared x. We have a common denominator of cosine x sine x, so we can write this as one fraction. Now looking at the numerator, sine squared x plus cosine squared x is our main Pythagorean identity, so we can rewrite that as 1. So 1 over cosine x times sine x. Now we can break that apart into 2 separate fractions. Since we're multiplying, 1 times 1 gets us 1. Cosine x times sine x gets us back up here. The reason we want to break it apart into 2 separate fractions is because if we looked at the beginning, we had 2 different trig functions that were being multiplied. The last step is to use the reciprocal identities. 1 over cosine x is equal to secant x, and then 1 over sine x is cosecant x. So we used trig identities, rewrote that initial portion, the left side, and we simplified it to get it equal to what we wanted, secant x times cosecant x. Example 3, we want to prove that cosine of t over 1 minus sine t is equal to 1 plus sine t over cosine t. When trying to determine which side we should start with, which side's more difficult, if we look at the denominator of the fractions, on the left side we have 2 terms, on the right side we only have 1 term, so we're going to start with the left side of the equation. Because we have more terms in the denominator, that's generally going to be more difficult, so that's the side we want to start with. So starting with cosine t over 1 minus sine t, when we have these 2 terms, we can multiply by the conjugate of the denominator. So if this is 1 minus sine t, the conjugate will be 1 plus sine t. So we're going to multiply the numerator and denominator by 1 plus sine t. And then if we leave the numerator in factored form, we have cosine t times the quantity 1 plus sine t. In the denominator, if we FOIL this out, 1 times 1 gets us 1, 1 times sine t plus sine t, a negative sine t times 1 minus sine t, and then if we have a negative sine t times a positive sine t, we get minus sine squared t. In the denominator, we have a positive and a negative. Those will simplify out, just leaving us with 1 minus sine squared t in the denominator. So now we have cosine t times the quantity 1 plus sine t all over 1 minus sine squared t. Looking at the denominator, this is our Pythagorean identity. If we would take sine squared t plus cosine squared t equal to 1 and rearrange that, we know 1 minus sine squared t is equal to cosine squared t. Now between the numerator and denominator, we have a common factor of cosine t. So we can cancel that out with the squared. Now we're just left with 1 plus sine t over cosine t. And that's what we were trying to rewrite the left side of the equation to equal to in the beginning. Now example 4, we want to prove that cotangent squared u divided by 1 plus cosecant u is equal to cotangent u times the quantity secant u minus tangent u. In this case, when trying to determine which side of the equation we should start with, on the left side we have a fraction, on the right side we have multiple terms, but we don't have a fraction. So we're going to start with the left side and see if we can rewrite it to get the right side of this equation. So if we start with cotangent squared u over 1 plus cosecant u, we can use one form of our Pythagorean identities to rewrite cotangent squared u. I know that is equal to cosecant squared u minus 1. The reason we would do that is because now in the numerator we have a difference of 2 squares, so we can use ideas from algebra to factor out cosecant squared u minus 1. This will factor into cosecant u plus 1 times cosecant u minus 1. Once we have it in factored form, we can see between the numerator and denominator we have a common factor of cosecant u plus 1, which will simplify out, leaving us just with cosecant u minus 1. So now we have cosecant u minus 1. Recall that we're trying to get this expression to equal cotangent u times the quantity secant u minus tangent u. It's going to be very difficult to try to figure out how to rewrite this to get it into that form. So one strategy we can use is now we can start with the right side of this equation and simplify it to see if we can get it to equal cosecant u minus 1. Because then based on the transitive property from geometry, if we rewrite both of these expressions to get it to equal the same value, the same expression, that implies they must be equal to each other. Now we have cotangent u times the quantity secant u minus tangent u. The first thing I'm going to do is rewrite each of these functions in terms of sine and cosine. Now we have cosine of u over sine u times the quantity of 1 over cosine u minus sine u over cosine u. Now we can multiply and distribute the cosine u over sine u to each of the terms in parentheses. So we have cosine u over sine u times 1 over cosine u minus cosine u over sine u times sine u over cosine u. Now we're going to look and see if we can get anything to simplify. In the first fraction, we have cosine u over cosine u, which will simplify. In the second fraction, cosine u over cosine u and sine u over sine u. Now in the first fraction, we're left with 1 over sine u minus 1. The last thing we need to do is use the reciprocal identity to rewrite 1 over sine u, which is cosecant u minus 1, which is what we were trying to get it to be equal to in the beginning. So we simplified the left side of our identity to get it to equal cosecant u minus 1, and then we simplified the right portion of our identity to get it to equal cosecant u minus 1. Based on the transitive property from geometry, since we simplified both sides to get them to equal the same expression, they must be equal to each other. A few things to remember when completing these proofs. First, there isn't going to be one way to complete the proof. You could use different identities, take different steps, and still complete the proof. It's just some paths are going to take longer than others. The second thing to remember is that this is a proof. You have to show all the steps. You cannot skip steps when completing a proof.